So this section is going to talk about IPv4 classes, subnet mask, public versus private IPv4 addresses, find the number of hosts per network, subnetting, and one size versus variable length subnet mask, and subnetting maths. So this kind of things we're going to talk about around subnetting. So first of all, what is a subnet? So subnet is basically a network, and from the big network we make a lot of small network, sub-network. So that's actually the subnetting. So why we need the subnetting? If we looked at these pictures, we have couple of PC1 and PC2, and we have some small device. All the networking device in our network, they need IP addresses. So for that, we can assign IP addresses, but how we going to assign the IP addresses? So that things we're going to look at in details. So normally for any network, we assign the IP addresses. For example, we said 192.168.10.1, 192.168.10.2. So like that way we assign the IP addresses. So IP address actually is written in decimal number, IPv4. Example, we have a PC, that PC we assign 192.168.10.1. This is, I just make up these addresses, so is nothing special here. And 2, so it's basically 10.2. So we got 10.1, 10.2, like that. So how actually we got these IP addresses? So let's have a look the how IP address assignment actually happened. So total IPv4 addresses we have 256. So IPv4 actually, IPv4 address we call it 32-bit address. So what is bit? Bits mean ones and zero, right? 32 bits means 32 ones and zero, ones and zero. Like this. This is 1 is a bit, 0 is a bit, 0 bit, 1 bit, 0 bit, 1 bit. Like that. In one address we have 32 bit addresses. So how we write these addresses? We say 4 multiply 8 bit equal to 38 bits. That means, let's say we have a decimal number 192.168.10.1. This is one of the addresses we have, but this addresses we have 32 binary bits in here. For 192 we have a 11000000, like that. That's the binary. So how we get the binary? So it is important to understand the binary, because if you understand the binary, then you can understand the network bit and host bit, all those stuffs. Let's say 192 decimal number. So we have a 8 bits in each decimal number. So 8 bits has a value such as 2 to the power 0 equal to 1, 1 equal to 2. This is actually we write down in slightly bit different way, like this way. Then it will be easy for us to look at. Yeah. So 8 bits means all equal to 0. Okay, 8 bits has a value. 8 bit means 2 to the power 0 equal to 1. Then you have a 1 equal to 2. Then 2 to the power 2 equal to 4. 2 to the power 3 equal to 8. 2 to the power 4 equal to 6. 2 to the power 5 equal to 32. 2 to the power 6 equal to 64. Right? That's why That's how we write down the bit values. So each of the bit is important. So if you want to get 192, we're going to add the value from left hand side to right hand side. So to get 192, we need 128 and 64. So other bit values we don't need. So what we put 1 1, then we put 0.0.0.0.0.0. We need these two values, but other 6 value we don't need. That's why we put 0, all 6 zeros. And 168, for that, to get 168 we need 128 plus 32, so that makes 160, plus we need 8, altogether 168. So it's basically, so we put 1 because we need this one we don't need, we put 0. 32 we need, we put 1. 16 we don't need, we put 0. 8 we need, we put 1, and rest we put 0, 0, 0. And similar way, to get 10 we need only 8 and 2, so rest we don't need, so you put all 0 except these two, we put 1. To get 1 we put all 0 and last one will be 1. Let's have a look how this IP address assignment actually done. So IANA, they are the main provider. They're like internet address number assignment. So these people, they actually assign the IP address to the RIR. RIR stands for Regional Internet Registries. So they are like in another region, we can say. But under each of the region, we have different. This is the actually region like Asia, Africa, Europe, North America, South America. We are under Asia Pacific. So at first, IANA, they assign the IP address block to RIR, then RIR assigned to particular region, and each region they assign to the particular country, and from the country whatever ISP assign to the company, and company will get the IP addresses. That's how the IP address distributions happen. Yeah, it's actually, that's like a breakdown, but if you looked at IANA, they provide to RIR, then they provide to, like for example, Asia Pacific, and then Asia Pacific will provide to Australia, then Australia will provide to ISP1, like that, and ISP1 to company 1. That's how the IP address distributions happen. So IP address, we have a public IP and private IP. Public IP means that IP address used for routing purposes. They are unique in all over the world. For example, we have our mobile phone. So mobile phone, we have a public addresses, and private addresses we are using internally to the organizations. For example, we have a company, hundreds of people, they are working in the company. So all these people, they are not using the public addresses, they are actually using the private addresses. Private addresses, they are not routable to the internet, but we have a network address translation mechanism. With that private address, they can communicate with the internet after translations. But public address is an internet address. They are routable to the internet. Private addresses anyone can use. We are using the private address internal to the company. Now let's have a look at the IP address distributions. So IP address range will be 0 to 255. That is the IP address range. Any IP address we write down, it has to be in between 0 to 255. And how the IP address distributed, it has a class A. Class A address is 1 to 126. All the address range from 1 to 126, they are class A. 128 to 191, class B. 192 to 223 is class C. Then 224 to 239, that is class D. 240 to 254 is class E. So 0 number is used for network purposes. To define the network, we using the 0. For example, we say 192.168.10.0. 0 means we talking about the entire group. We cannot assign IP address as like a 0 to someone, right? We need to put either 1 or 2 or something like that, not 0. So 0 means network ID. Then another address missing in here, see the 127. If any address start with 127, that means it's called loopback address. What is loopback address? Loopback address is used to check or test our own network connectivity. For example, my IP address may be 200.1.1.1. So I can tell the router or like my PC to check my own loopback. Loopback means your own IP addresses is referring to. Normally, we using the loopback address for to check our own network connectivity. This is class B, class C. So another thing is the class D. Class D IP address normally used for multicast purposes. We don't use class D addresses for normal, IP address assignment. And class E we're using for research purposes. But normal IP communications, we are using this block. Normal, like, for example, hundreds of people is working or like, public communications in the internet, we are using the IP address from this range. But yeah, let's talk about those private address range. Private address range, it's any address start with 10, any address start with 172, any address start with 192. Roughly around those addresses, they are the private address. But it has a range as well. I'll show you the range, but mostly 10, 172, 192, those addresses, they are like a private addresses. But later on, we're going to find out like, the entire range. But other than that, all addresses, they are public addresses. Okay, so what is 0? 0 is used for network purposes. And 255 using for broadcast purposes. So what is a multicast, broadcast, and unicast? So what is unicast? Unicast means like we doing one-to-one communication, that is like a unicast communications. Sometimes we have a more people, so some classes we have a 4 or 5 people. Then what we do broadcasting. So that's a broadcast. Broadcast means to broadcast to everyone. So unicast is one-to-one, broadcast is one to everyone, multicast is a group communications. For example, maybe I have 2 video groups. I'm communicating something with you, and maybe I have another group. I'm communicating with them about different stuffs. So that's kind of like a multicasting. Multicasting is like a group communications. So in our networking field, all these unicast communications, multicast communications, broadcast communications, always be using this kind of communication. Okay, so now let's go back to that addresses, this one, 192.168.10.1. So this addresses, what is the mask? Let's talk about the subnet mask. If class A, subnet mask will be 255.0.0.0. If class B, 255.255.0.0. If class C, 255.255.255.0. So what is a subnet mask? Subnet mask actually tell us two things. If we see the subnet mask like that, that means it's a, and if any address start with this number, and if it is the mask, that means this address is belongs to class A, and this is the default mask. This is the default mask for class B. This is the default mask for class C. So if we do the binary,
does it mean we're using class C for 192?
yes, at the moment we are using the class C, correct. Let's have a look the class C by class C addresses. See, this is the class C address. So based on that informations, we have this is the class C subnet mask. But class C subnet mask, if you do the binary, right? What is the binary of 255? It will be all 1 1 1 1 1 1 1 1 like that, and then 1 1 1 1 like that, 1 1 like that. So 8 8 8. So 24 bit is 1, and another 8 bits is 0.
Yeah.
Now 1 bit is network bit, 0 bit is host bit, right? So that means we have 24 network bit and 8 bit is host bit. Yeah, 1 bit we call it network bit, 0 bit we call it host bit. So with the 24 bit, there's a formula like what we can do with the 24 network bit. 24 network bit, 2 to the power n equal to number of network. So 2 to the power 24, that many network you'll be able to create. 2 to the power h minus 2 equal to number of host. So 2 to the power 8, because we have a 8 here, 8 minus 2 equal to 254 host. What is a host? Host means individual PC. Individual PCs, their IP addresses, they are the host. PC, servers, mobile phones, they are all individual host. So we can see that from this number we have this is the breakdown of this number. This is the decimal number where we get the mask, because this is a default mask for this class. And then if you do the binary, that's actually looks like this. And based on the formula, this is a formula. We can see that how many number of network we'll be able to create, how many hosts we'll be able to create. And then after that, what can we do with this number? So for any network or any subnet, if we need to set up for our network, we need to find out few important information, such as what is the network ID. So in this case, we say network ID is 10.0 because 0 is indicating the main network.
Yeah.
Mask, this is we get from our formula. From here, default mask is this one. What will be the first IP? 192.168.10.1. What will be the last possible IP will be? Broadcast means last possible number we using in our network for broadcasting purposes. Automatically IPv4 network select the last number for broadcast purposes. First one and then last one we never assign to anybody. We reserve that. So that's why -2, this -2. Now problem is, if we have a 254 people in our company and if we assign IP address from the same network, what will happen? Or like now we are one-to-one communications. If we have another 10 people and everybody communicate, then what will happen? It will be like chaos, or like it's not be so nice. So that's why if we what we do, we break down the network. For example, this big network we break down to small network, and then we assign the those small network address block to certain department. and that is called subnetting. Like we don't want 254 people in under one network, so that's why we do the subnetting. So how to do the subnetting we're going to discuss soon. Like that. So now look at these addresses. If you make /26 and if we looked at the binary of the /26, we can see that 1.1.1.1. all 1, 8, so 8 ones, 8 ones, and 8 ones. That's 24, 25, and 26. And then rest we put 0.
Yeah.
So what we have done, we have actually /24. We want we want some 2 extra bit. That's why we make 2 extra bit, and now it is /26. And with that 2 extra bit, we actually can find out some information such as 2 to the power s equal to number of subnetwork. So 2 to the power 2 bits equal to 4 subnet. So that means if we need a 4 subnet, what we can do, we can increase the bits in here and we can create 4 subnet. If we need to create 4 subnet, we need to have a 2 bits. And if you have a 6 host bit, what you can do, 2 to the power h minus 2 equal to number of host. So 2 to the power 6 minus 2 equal to 62 host. So that means from this subnet, what you can do, you can create 4 different subnet. Under each of the subnet, you can have 62 host. It means 62 IP address will be available, which you'll be able to allocate for individual PC, servers or some other devices. Classful means they following exactly this range. So if you have a 192.168.10.0, and if you have a subnet mask exactly like that, we can say that this is a classful network. Okay. But if it is something not here, then that is classless network. But this is one of the classless addresses, and we can find out like 4 subnets. So we're going to learn how to find out the 4 subnets, and for each subnets, how to get 62 hosts. We're going to learn these stuffs. So first, what we do, we take a number called 256. This is imaginary number. We just imagine then this is a number, this is a formula kind of like things. As you can see, which by looking at this one is class C, but it doesn't follow the class C mask. It got some extra things, which is 192. That's things we call it interesting octet. Interesting octet. So this 192, what we have done, we subtract from 256 and gets 64. We are trying to find out the subnet.
Yep.
So always first subnet will be 192.168.10.0. With 0, you plus 64, this one. So your second subnet will be 192.168.10.64. Third one will be 128. Fourth one will be 192. That's why we're talking about 4 subnet. And what will be from the first subnet, first IP address will be 10.1. And then what will be the broadcast? Dot 63. Based on this information, we can create 4 subnet, and for each subnet we can have 62 hosts. Now let's have a look another example. In this example, we have another address, right? 172.168.39.169. This is a random address we picked up, and /19. /19 means at first you're going to check which class it belongs to. This is class B.
Yep.
So class B mask is 255, 255. It should be 00. But instead of 0, we have a 224. So what does it mean 224? Then you do the binary. Because if you do the binary, it will be clear for you.
Yep.
So all 81, 81, and then 111. So that means 224 means 111, right?
Yeah.
And rest 0. So now say, okay, this bit we call it network bit. Oops, whatever. This is called network bit. This one called sorry, not this one. This 3 is called subnet bit. So in here 16 bit is for network bit, 3 bit is subnet bit, and how many host bit you have? 5 plus 8 is 13 host bit. This is like one of the address given to us, right? From these addresses we need to find out subnet ID, mask, first IP, last IP, and broadcast IP.
Yeah.
Entire range you need to find out. So at first we find out. So first we're going to take a number called 256 minus 224. So how you get the 224? Because of this, /19, we get 224. And see, this one is called interesting octet, right? This is called interesting octet. So we have 256 minus 224. 256 minus 224 equal to 32, right? So 32 is our magic number. With that 32, we can find out all these informations. Okay?
Yeah.
So what do you do? This 32, we need to multiply with something that will give us a value. That value has to be equal to or less than this 39. Okay? So 32, if we multiply 1, we get 32, which is less than 39. So this is perfect. But if you multiply 2, then what will happen? It will be 64, which is more than 39, so which we don't want. So that's why we multiply only 1 and we get number 32. This is our subnet ID. So subnet ID will be 172.168.32.0. Where are you going to put the 32? We put in the middle octet because everything is happening in this middle octet. Okay? Now, how to find out? We find out our subnet ID. If we find out a subnet ID, our first IP address will be 32.1, right? And mask already we find out the mask. So these three informations, no problem. Now how to find out the broadcast IP? Subnet ID, which is 32, magic number, which is 32. So subnet ID plus magic number minus 1 equal to 63. And 63 is my broadcast IP.
Yeah.
172.168.63.254. This is my broadcast IP. So this is another way we can find out the entire range. In the exam, you may get one questions and say, okay, hey, could you please find out, is it a valid address or not? Or valid address means whether, like for example, 255 is not a valid address, 32 is not a valid address, but in between any number like 172.168.63.254, all the number is like a valid. So this one 192.168.234.10/26. This is another example, right? We want to find we want to find out the subnet ID, mask, first IP, last IP, and broadcast IP, right? These informations we want to find out. To find out the subnet mask. So subnet mask will be 255.255.192 because 2-bit extra, and if it is 2-bit, if we add 128 and 64, we'll get 192. So if we want to find out the all other informations in detail, so what is the first thing we'll do? We say we'll take a number called 256 minus 192. We get 64. That is our magic number. After that, with this magic number, we're going to compare with the octet. So if we have our if we have our subnet ID, or like any IP is given to us, and this is our mask. First thing, we need to find out the interesting octet value. What is interesting octet? If any subnet mask contain a different number than 0 or 255, then that octet we call it interesting octet. So this subnet mask, this is not 255, not 0. So that's why this is different. This is called interesting octet. In the same octet, we put actually in here. That's the reason we put in here. Yes, now it's okay. So now this 10 is also part of this interesting octet. These two things we need when you do the subnetting math. Now 256 minus 192, we get a 64. 64 we need to compare with 10. So if we multiply with 0, we can see the result 0. So 0 is less than 10. But if we multiply with 64, if we multiply with 1, we'll get 64, which will be more than 10. But we need a value which has to be less than 10. So only options we have, we can multiply with 0. So you get a number 0. And this is our subnet ID. Now 0 plus magic number minus 1, we get 63, and this is our broadcast IP. Right now, we got our subnet ID is 0, because once you get a 0, we put that value in here, 192.168.234.0, mask, which is 255.255.255.192. Then first IP is 234.1. Broadcast, we find out 63. So 192.168.234.63. And then last IP will be 62. So this is the complete subnet informations for this one. Now another example. /27. So this is 192.168.34.69/27. /27 means if we get the mask 255.255.255.224. So after 24 bits for class C, we have a 3 extra bit. If we add those 3 bits value, we get 224. So 256 minus 224 equal to 32. This is our magic number. So this 32 we're going to compare with 69. So 32 multiplied with 2, we get 64. 64 is less than 69. That is our subnet ID. If you want to get a broadcast IP, 64 plus 32 minus 1 equal to 95. This is our broadcast IP. So that's our subnet ID 34.64. This is our mask. This is our first IP, last IP, and broadcast IP. So that's pretty much the information about the subnetting.